All right, so again, Google, the Google Classroom. The question of the day went out this morning. I think it went out a few minutes ago. It asked for what is the coordinates for the third example on our notes today. So we're going to do that. We're going to do a very similar thing today. I want to do a couple notes. I want to do about 4 problems today in class. I know that seems a little odd. Then I'm going to give you time to work on your homework. We have a assignment that I handed out yesterday on the Zoom. It's in your Google Classroom. If you can't find it, it's a worksheet. I have a picture of the worksheet in case you can't open the Word document, because some people are on like the Chromebooks and it doesn't have Word. So I have just a picture. You can open up the picture. You just do all the work on a separate sheet of paper and then take a picture of it, and then you'll submit it back to me on Google Classroom. Does that make sense? Even for you in here. So don't be thrown off by that. I just want you getting used to that setup where you're always submitting it to me online, even if you're in class or not. The reason being is that at some point we will have to be online only. And so I just want you getting used to that concept of what you have to do. Make sure you have a clear picture of your homework and whatnot. So, and you can add multiple pictures. I had somebody in the other class do that where it didn't fit on one page when they were drawing it. They were drawing way too big. So they just took multiple pictures and attached every single one. So that's fine. I can do that too. So, okay. Are we ready to go? Everyone's got notes and everything? I don't want to ignore the people at home. So, okay. Let's take a few notes. I'm going to just sit here and kind of write down some stuff. Sorry, I must have my Wi-Fi still turned on. Okay. Let's start with, let's do a few notes here. So remember, the whole goal is to figure out where lines cross, right? So let's just do a first example here. Let's do something like x plus 4y equals 6 and 2x plus 2y 2x plus 2y equals 6. Let's do that.
Your screen isn't working for over here. Like, we can't see it.
Weird. Here, hold on. It's on. Is that better?
Yep.
Okay, weird. I didn't really do anything. I just moved my mouse. That's odd. Hi.
Just looking at numbers.
Oh, yeah, this class is actually pretty balanced. I looked at my my period 4, and that's a small class anyway. 1 kid is gone.
The information you're delivering right now,
Yes.
the distance learners are responsible for today.
Yes. They're online with me right now.
And then vice versa for these guys tomorrow.
Yep.
Got it.
So, yeah. So, okay. So, all right. But yeah, so that was Mr. Haig. Sorry. He popped in just to say hi and kind of check how classes are looking today. So, all right. So this is my first problem. Goal today is to graph these, right? So you want to get them to that slope intercept form where you have the y on the one side and then the mx plus b. So in that, like that first example there, the top one, I need to get that y by itself. So what do I need to move first on that top one? Say it again. Yeah, I need to move the x. So when the x moves across, I'll put it in blue here. Hopefully you can see this. I'm going to move this x across and becomes negative. Anytime it moves across the equal sign, it becomes automatically the opposite. So it's going to be 4y equals negative 1x plus 6. And there is a 1 in front of the x, so when I move it across, it's just negative 1. So, okay, and now the goal is to get the y by itself. So, because there's a 4 in front of it. So what do we have to do with the 4? Divide it. We have to divide that 4. So what we're going to end up with is if I divide everything by 4, divide by 4, divide by 4, divide by 4, you're going to get a weird decimal, which is totally fine. And this is the one I was trying to talk about yesterday, where you're going to get some crazy numbers. It's totally fine when you get that. What we have here, the 4s would cancel out. So this is what that first equation will look like. It'd look like y equals, and then the number in front of x is negative 1 over 4x. And then the number that's in the back, 6 divided by 4. If you check on like a calculator, 6 divided by 4, that should be 1.5. All right, questions so far on what we've done? Okay, I'll take silence as, yeah, it looks okay. I'm kind of getting that, or maybe too scared to ask. Okay, second equation. Second equation. This one takes about the exact same effort. So what do I need to do first in that second one? Move the 2x. Okay, so if I move the 2x across, it's going to do the same rules, right? You're going to move the 2x to the other side and it becomes negative, just like the other one. So this will be 2y equals negative 2x plus 6. And then the last step is to divide everything across, right? Divide everything by 2 so that the y is by itself, just like the last one. So the last one we did 4, this time we're doing 2 because there's a 2 in front of the y. So if I divide everything by 2, this one works out way better. It's negative 1x plus 3 because everything divided by 2 is a very nice clean number. Okay, so there's the second equation, and this is the first one. Sorry, it's a little messy. Let me put a line in the middle there. There we go. Separating the two. Again, if you're at home and you have questions, don't be afraid to ask. Type in the chat or ask away. All right. Now we have to go graph. So on the top one, how do I graph that? Where do I start on that top one?
6.
Say it again?
6.
Nope.
1.5.
1.5. Yeah, because when we rearranged it, the 1.5 is the number we have to start with. So this is the first starting number. This is my B number. Then the MX is where I'm going to go from there. So I have to start at the 1.5. Now that's a weird number. It's a decimal. So we still have to start at a decimal. That's fine. I'm going to keep this in blue. Okay, so I'm going to start at 1.5. That's about right there if you can see that. So, yeah, you can kind of see it. Hopefully there's no glare. If there's a glare on the board, just let me know and we can kind of move to a safer spot. It's right there, 1.5. And then from there, I have to use my slope. So what does my slope tell me to do from that dot? Yeah, down 1 over 4. That's the slope. That's my M, right? It's negative, so I'm dropping, and then it's always going to the right, and the bottom number goes to the right, so I'm going to the right 4. So from here, go down 1 over 4. 1, 2, 3, 4, and put a dot. And then down 1 over 4. 1, 2, 3, 4. And there you go. So there's my line on the first one. Hopefully that makes sense to you. Okay, now the second equation, this one should be easier. I'm going to put this one in black now. I'm going to start at 3 on this one. This is my B number. I'm going to start at 3 on the second one. And my slope is 1 over 1. That's my M. Right? So I'm starting at 3. So positive 3, that's right here. And then going down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And I kind of see where I think I'm going to cross. So I'm going to highlight this here in a second. So even if you're in class, I'm going to zoom in on that just for a second so you can see that. I think I can see where it's crossing, so let me zoom in here so you can see that. I think it's crossing about right there. Let me zoom in really far here. There you go. There. What is that coordinate right where they're crossing?
Positive 2, positive 1.
Yeah, that's the coordinate right there. So you're absolutely right. The coordinate that we're getting, let me get this out of the way, we are going to cross it 2 over 1 up and down. That's my X, that's my Y. Remember, the right and left numbers first, and then the up and down numbers second when you write coordinates. And you're absolutely right. Positive 2 comma 1. That's what we're looking for. All right. All right, questions on the first one? Okay, now, the reason I bring this one up is we did one of these yesterday where it was kind of a weird look to it. The problem was, it didn't look great. It was one of those things that the lines were just kind of tilted about the same direction, kind of like this one, and it was really hard to see. That's the failing that this method has, that it's not perfect. It's kind of messy because you have to be really exact on your drawings. And still, sometimes like on the last one or the second one we did yesterday, we had to literally guess at where it crossed. That happens. Like this one, I think it was more clear on this one, but it's still one of those things that's still messy. And so the goal today on the fourth example, I want to introduce what we're going to do next. It's an introduction to like the stuff we're going to start maybe tomorrow or Monday. So again, we're going to review some of the stuff tomorrow. So if you're at home and you'll be in class, we'll do a couple more of these tomorrow so you get some chance to work on your homework. So, all right, let's do a couple more because I do want to give you time at the end of class where you can work on your homework. You can ask questions because I know you have to have some. It's not easy to do stuff like this at home sometimes. So, all right, let's do another one. Let's do a quick one here. So let's say, okay, let's go to the second page here. Again, I'll have all these screenshots on my website tonight. I've been trying to do that right after school. I think yesterday was way faster. Google must not have been as inundated. The videos were up really fast, I thought, yesterday. So they were up by 6 o'clock, I think, yesterday, as opposed to like 10:30 the day before. So that was good. So all right. So second equation. Let's go with y equals 2x plus 4. And the next one, let's go with negative 2y equals 1x plus, no, let's go minus 8. Minus 8 here. Let's do this. So this is my second equation out of the 3 I want to do today. Or 4, technically. 3 that I want to graph. Alright. Alright, so let's draw the first one. It's already in the right form. So on that top one, where do we need to start? 4. I don't need to rearrange anything. It already is y by itself equals sign mx plus b. So we're going to start at 4, I agree. I'll put the top one, maybe we'll put it in like a purple color. So we'll start at 4 on the y-axis. Again, you're always starting on the y-axis up and down. So you just have to find that number, positive or negative, just go find it. And then where do I go from there? What do you think? Yeah, the slope is 2 over 1, right? The top number is how you rise or fall, and then the second number is always to the right. So I'm going to go up 2 over 1. I have to make it a fraction. So up 2 over 1, up 2 over 1, up 2 over 1. And you can kind of see the drawing that I have here. Okay, perfect. What about the second equation? What do we need to do on that one? Divide by negative 2. And I don't think we've ever divided by negatives. I think this is kind of the first time we've ever had to do this. So I'll put this one maybe in a green color. So I'm going to divide everything by negative 2. So on the second equation, if I divide everything by negative 2, that'll be a y. It'll be a 1, because negative 2 divided by negative 2 is 1. I'll just put a y. Bless you. And then I'm going to divide 1 by negative 2. So that's just negative half. You can put the negative sign wherever you want. And then negative 8 divided by negative 2 is a positive 4. So that's dividing everything. So again, on the slope, it doesn't matter where you put the negative sign. You can put the negative sign on the bottom with the 2, or you can put it on the top with the 1. It doesn't matter. 1 divided by 2 is half. You just put the negative sign on it. So on the second equation, where do I start? 4. It's the same dot. I'm actually starting on the same y-intercept. So that's where they cross. That's the point of intersection. That's the whole point. So I already know it. I don't even have to go further, but that's where they're going to cross. And then my slope is telling me to drop 1 because it's negative slope. So I'm dropping and I'm running to the right 2. That's the negative sign just tells me it's dropping. And then I always go to the right. So I'm dropping 1, running 2, dropping 1, running 2. And you guys get the idea where I'm going here with this one. But now, what is the coordinate though? Say it again?
0, 4.
Yeah, it's 0 right and left, up 4. Remember, the x number goes first, the y number goes second. So right and left 0, up and down 4. That's where they cross. Because again, remember, the goal is where do they meet? That's the whole point of this assignment that we're doing, right? All right, so that's the second one. They just happen to meet right on the same y-intercept. It happens. Happens quite a bit sometimes. Nice clean numbers. Okay, third one. This is the one that probably everyone's waiting for, right? The all-important one that you have to fill out for the Google form question of the day, right? What is the coordinate for the point of intersection for the third example? This is going to be the one we have to do. Okay. So third example here. Let's kind of walk through this one. So, okay, here we go. Let's go with 5x minus y equals, let's go with 9, and let's go with x plus y equals 3. So this is my third example. Okay, so this one, just like the others, you just have to rearrange graph. Is there a certain color you want the top one in? You just want it in black? You want it in any weird color? I got a bunch. Preferably not white. No preference. All right, let's go brown. It'll be kind of an ugly brown color. Almost looks black up here. Okay, top one. We have to rearrange, right? So it's not in the right form. I don't have the y by itself, so I need to move that x over first. If I move the x over, it becomes negative, so I have a negative 1y. If I move that 5x over, it becomes a negative 5x plus 9. So again, because when I move the 5x, it becomes negative when I move it over. The y stayed negative. That really throws people off. The negative sign is attached to the y. It's a negative 1y. Now, what's the last step? Divide by negative 1. And I don't know if we've ever had to do that where you have to divide by negative. I think we did it on the last one for the first time. So divided by negative 1, here's what I get. I get y equals 5x, because the negative 5 divided by negative 1 is positive 5, and then 9 divided by negative 1 is negative 9. This is the one I'm drawing. Again, the y is by itself. I have the x. I have that constant in the back. Okay, so on this one, I'm going to start at negative 9. So I'm starting at negative 9 here. Oop. Oh, there's negative 8. Negative 9. Again, my graphs go to 12. That's how I knew where to put that dot. So I'm starting at negative 9. And then what is my slope telling me to do? It's 5 over 1. So what's my slope tell me? Yeah, rise 5, because it's positive slope, it's positive 5, so rise 5, and then run 1 to the right, because you can always put any whole number over 1, so that's how I know that. So rise 5, 1, 2, 3, 4, 5, run 1, 1, 2, 3, 4, 1, 2, 3, 4, 5, run 1, 1, 2, 3, 4, 5, run 1, and you get the idea. I can pretty much see where my line's going here. I usually draw a few dots. You don't have to. Some people just get away with drawing one or two dots. Cool. It's really handy on these if you have a ruler. That way it's like super exact. You can kind of see it. So, all right. Let's go to the next one here. So, the second one, I'm going to put this in a different color. Let's go like a brighter color, like an orange color. All right. On this one, really all you have to do is just move the x. So if I move this x across, it becomes negative. That's really all I have to do on this second one, or this third problem, I guess. So move the x over, it becomes negative x. So in this one, what? Starting at positive 3, that's the constant in the back. Starting at 3. And then my slope is negative 1 over 1. That's my slope. There's a 1 in front of the x, so it's 1 over 1. So I'm dropping 1, running 1. So drop 1, run 1, drop 1, run 1. I can already see where they cross. Drop 1, run 1, drop 1, run 1. And so this has the same coordinate that I think we had earlier. It's over 2, up 1. That's the answer I want for the Google form question of the day. Right there. Where do they cross? They crossed at 2, 1. All right. I'm going to stop talking. Sorry, I talk a lot. Go kind of quick sometimes. Is there any major questions you're having about this process? Now, why I'm going this direction? Why did I start here? Hopefully, we've done enough of these in the last couple days. You're starting to get a little bit better at it. I don't expect you to be experts, but I want you to be comfortable. I mean, I don't want you to be lost. It's the last thing I want you to be. So, okay. Fourth, this is my last example of the day, and then I'll give you about 10 minutes where you can work. I'm going to work on this for about 2 minutes here. I want you to see something, but I also want you to have this problem written down. Okay? This is the important one. I'm going to use this problem as the example for my next one, okay? I know that seems a little weird. I'm going to show you the new method we're going to be learning potentially starting either tomorrow or Monday. So I'm going to start maybe doing 1 or 2 of them tomorrow, and then maybe 2 or 3 of them on Monday next week. This is the new method. It is, I believe it's significantly better than graphing. Graphing is messy. You need graph paper, you need to be super exact. It's kind of a pain in the butt, I understand. So, again, if you guys are working at home and you're working on this homework, I have graph paper in the back if you need it. It's in that little folder back there. It's right in the basket right now. It's the gray and red folder. So even the people that are at home right now, when you come here tomorrow and you want graph paper to do your homework, that's fine. You can take graph paper, you can draw all those problems out, and then take a picture of it and submit it to me online. So I don't have a problem with you doing that. Maybe you already started your homework, I don't know. Maybe you already have it done. I haven't looked at who's turned it in yet. It's due tomorrow at like midnight tomorrow. Okay, okay, here's what I'm going to need. I'm going to need somebody to tell me this problem here in a little bit. Does somebody have it written down exactly like the starting problem? Yeah, we have. Okay, so this is my last example of the day. It's the new method. This is called elimination method. So it's called elimination method. In other textbooks, previous textbooks, for my geometry and pre-calc, it was called linear combination method. That's what other textbooks have called it in the past. It is a very analytical way of doing this. Analytical means you don't graph it. You're doing everything by just number crunching on a piece of paper. It's not setting up tables. You're not guessing. It is literally this weird strategy that works and gives you the right answer. But again, it's very analytical. So, very analytical. All right. So let's start with the problem. So I need, what was the problem we had to start with? It was 5x minus y equals 9. And what was the other one? It was
X plus Y.
okay, x plus y equals 3. Okay. Okay, I'm going to do it for this problem. We already know the answer, right? The answer on this problem that we just put on the Google form was 2, 1, right? We already know that. I want to prove it. I want to show you a different strategy to get the same answer, and you can use this as like a fail-safe to check. I don't do this in my head when I'm making these problems up. I'll show you that strategy possibly tomorrow, how I've been making these problems up on the fly so that they work out to be nice, pretty numbers. Just a different strategy that I use. So, all right. So what you want to do is you want to draw a line underneath your problem. Okay. All right. And what we're going to do, and I know this seems really weird, you want to check to see if one of your variables, one of your letters, has the same number in front of it. So up there for x or y, does one of the letters have the same number out front? Right? Do you agree with that? That the y's have 1s in front of them? Yeah? That's what you want to make sure of. This is where this method comes in handy. One of the variables has to match, has to have the same number out front. Now, since it does, you're allowed to do this strategy, this elimination method. And if they don't match, you have to do some other work before you can get to this process. This method is super easy. What you do is you put 1s in front of everything that needs variables. So I put a 1 in front of my x, put 1s in front of my y, so I did match. You want to make sure that one of the letters you're picking, they have the same number out front, but they're opposites. So do you agree it's a 1 and a negative 1? So that's another thing you have to check for. Again, we'll explain this more tomorrow and Monday. And the idea is that once it's set up like this, where one of the letters is perfectly matching and they're opposites, one's negative, one's positive, you can add straight down like it's a column, like it's column method in Algebra 1 in elementary days. So what I mean by adding straight down, what is 5 plus 1 if you add it straight down? 6x. Okay. The y's, 1 and a negative 1, what would happen there? Make 0, right? 1 and negative 1. So those are gone. They canceled each other out. They eliminated each other because 1 and a negative 1 literally add to make 0 y's. And then when you add the 9 and 3 straight down, what does that make? 12. And now you just solve for x. How do I solve for x when it's 6x equals 12? Divide by 6. If I divide by 6, your answer is 2. Oh, same number, right? And then to find the other answer, to figure out, okay, well, how do you figure out the 1? You just take the 2 that you just found and plug it back in. You plug it back into whatever equation you want. I'm going to pick the second equation. I think the second equation looks pretty easy, right? This is a pretty easy looking equation. I just plug the 2 in for x, because we already figured out x is 2's. So common sense, what does the y have to be so that it adds up to be 3? Y would have to be a 1. 2 plus 1 is 3. So, duh, or you just subtract 2 to the other side. I don't know how you want to think of it. It's a different strategy. It's very analytical. It works every time, literally every time, whatever problem, even on decimals, it will work. It'll tell you the decimal that you need to get. Now, obviously, I made this problem, I designed this problem in such a way that it works out very nice and clean. But it can get pretty messy. So that's what we're gonna look at possibly tomorrow, starting tomorrow, and then we're gonna look at them a lot on Monday next week. So don't feel like you need to be an expert right now. I just wanted to introduce this today. So don't feel like you even need to know how to do it before you walk out of here. Okay, any questions? Okay, at home, if you have questions, you can pop them in the chat. I'm gonna leave it on for a while, so if you want to stick around, you can. If you guys want to take off, you can. You have your homework. It's online. It's that worksheet that I put on Google Classroom yesterday. I have a Google question of the day, so go answer that. You know the answer. It's right in front of you. For those in here, you have time to work on your homework. So I still want you to fill out the Google question of the day. Do that every day, no matter if you're here or not. So take time to do that. But thanks for being here. So, okay, everyone left. Okay, now, honest question, because you guys are my guinea pigs in here. Is that okay? Is this okay that I write like that? Or is this hot garbage and you want me to write on the board with markers again? I don't know. Does this work for you? I don't want to be that person that sits at my desk all day. I hate doing that. I like walking around, but I need to make sure that the people at home get the same notes as you're getting, and I think this is easier for everybody. So, I don't know. I just don't want to leave the people at home alone. I fear that. I want you to get the same math as everyone else. Okay. All right, I'm going to stop the camera here.